micrometers apart. Okay, that is this number here, right? This is 0.74. Guys, can we be quiet? So that's this guy, right? 0.74 times 10 to the minus 6th, right? The lens has a diameter of 4.2 millimeters. That's this guy here, so that's 4.2 E minus 3, right? Okay. The laser has a wavelength of 780 nanometers. Well, that's this guy is 780. Yeah. And what must be the maximum distance? I guess we're solving for D. So that's our question mark, right? This guy here is 4.2. This guy, this guy is 4.2 E minus 3, and the distance between the pits is 0.74 micrometers. E to the minus 6. Micro is minus 6, right? Yeah. So now the thing we're solving for is D. D is going to be it's going to be, what? Yeah, you can. You can borrow this one right now. This one later. Okay, so D is going to be, what's it going to be? It's going to be this times this divided by this, right? So 0.74 e to the minus 6, right? Times 4.2 e to the minus 3 divided by 1.22 divided by 780. I'm getting that D is 0.003266, right? So about 3.3 millimeters. Is it reasonable that the thing is that far from the disk? It could be closer. 3 millimeters is like that far, right? That's actually pretty far from the disk. It could be closer. I know that magnetic read-write heads are way closer than that. They're like microns, I believe, away from it, a fraction. Yeah, that's right. That's true. Right. Anyway, that's one of the calculations. I want to show you some pretty pictures. These are other forms of data storage. The RAM is the stuff that's dynamic, that when you turn the computer off, it goes away. Cache is just RAM, by the way, that's on the processor, so it's closer and therefore faster. You're just, right? Okay. Flash memory are gates that actually can hold the information even after you shut the power off. The thing you need to know about these is that writing to them is destructive. I think you can only write to them on the order of 100,000 times, and then they wear out. Because you actually, yeah, like flash drives, right? Or SD cards or things like that. Anything where you can power them off, right? Core memory was an old-fashioned type of memory, stable memory. I'll show you a picture of that. Magnetic is like hard drives, right? We're using a lot of hard drives. Still, I don't know when that's going to end. And then, of course, optical things like we've talked about. This is a piece of RAM. I don't know which kind of RAM this is. I think it's very old. Okay. Notice how many of these guys there are. 8. 8 on this side and 16. Do you suppose that each one of those handles a bit, maybe? And that they work in parallel, so when there's a read requested, this one goes, okay, I got the first bit. Who's got the second? Well, you know, there we have it, right? Okay.
Do they still yell like that?
Yeah, they do. Right. This is flash memory, a picture of just what's inside there. There's wires and stuff. This is, this is really, really old. This is like stable memory from like the 60s or 50s or something like that. Magnetic core memory. Each one of those things is a little magnetic core, kind of like this, only way, way smaller, because this stuff's like thread, right? And they sewed this together. Basically what they did was the people that didn't do very well on the atomic and nuclear pre-quiz and skill set, they hired them to sew this together by hand. Okay? Yeah. Yeah. And they're good jobs too in technology. Right? There's a hard drive, and there's a black screen because I got a handout here.
Whoa. Skill set's not written on the agenda, right?
It's my liberal agenda.